channel. So in this slot, we're going to discuss chapter 4 polymers. All right, form 5 chapter 4 polymers. So we start with definition of polymer, monomer, and polymerization. Polymer is known as long chain molecule made from combination of many small repeating basic unit known as monomers. Monomer is known as small identical basic unit that forms the basic unit for a polymer. Polymerization is a process of combining monomers to form long chain molecule known as polymers. Take a look into the diagram. So this diagram is made up of same type of monomers. When same type of monomers combine in a repeating sequences, the process is known as polymerization. And we have two type of polymerization. When same type of monomers combine together, this reaction is known as addition polymerization. Therefore, this will be monomers. When these monomers combine in a repeating sequences, they form long chain polymer. So when there is a different type of monomers with different functional group, they combine together, this type of reaction is known as condensation polymerization. So we have two type of polymerization. One is addition polymerization, where the same type of monomers combine together. Another one is known as condensation polymerization, where the different type of monomers with different functional group combine together. I'll move on to the point number 4. Point number 4, polymer is a macromolecules. It's a macromolecules that contains thousands of monomers which combine in a repeating sequences, and they have a large relative molecular mass. Properties of polymers are very different from the properties of its monomer. Polymer can be classified based on their sources, properties, and also polymerization reaction that form them. We move on to the classification based on their sources. So the polymer can be classified based on their sources, whether they derive from the natural material or synthetic material. Sources of polymer, we have natural polymer that is exist naturally, where they found in animals and also in plants. And another type of polymer is known as synthetic polymer, is known as man-made polymer, and produced through polymerization reaction. This polymerization reaction, we have two type of polymerization reaction: addition polymerization, where the same type of monomers combine in repeating sequences form long chain known as polymer. And we have another type, condensation polymerization, where the different type of monomers with different functional group, they combine together and form long chain known as polymer. So it's produced through the polymerization reaction in laboratory and also in a factory. So we try to check example of polymers, natural polymers and their monomers. Natural polymers is made up of the combining of monomers in repeating sequences form long chain, and the monomer is known as basic small identical basic unit. For the protein, the monomer name will be amino acid, and starch will be glucose, as well as cellulose will be glucose. All right, so we try to go for natural rubber. Natural rubber, the monomer name will be isoprene, or we have another name, 2-methyl but 1,3 diene. The fat will be fatty acid, and also another monomer is known as glycerol. To the next part, I will focus on the type of synthetic polymer. We have three type of synthetic polymer. Start with thermoplastic, thermosetting, and elastomer. So we check the thermoplastic polymer that are transparent, and mostly this polymer is made up of addition polymerization. So we try to check the properties of thermoplastic. Thermoplastic polymer can be repeatedly remolded, or can be remolded many times and upon heating, and can be recycled. When the thermoplastic is heated, the polymer chain can slide against one another. Thus, this makes the thermoplastic is soft and can start to melt. When the thermoplastic is cooled, the polymer chain can stick to one another and become sticky. So the properties of thermoplastic is not heat resistant, elastic, can bend easily, light, and can be molded. Example of this thermoplastic is as polyethylene, polystyrene, perspex, and nylon. Move on to the next one, thermosetting. The thermosetting polymer, when we see the structure or diagram, there is a cross-link present between the polymer. So this polymer is hard and also strong. So this polymer cannot be remolded. cannot be remold after eating, or we can remold only once and after eating, and also this one disintegrate or burn upon eating and cannot be recycled. The properties of thermoset are heat resistant, are long lasting, and can be mold once only. Example of thermosetting polymer is bakelite, melamine, and epoxy. And the last type of polymer is known as elastomer. Elastomer polymer is elastic. It has elastic properties, can be stretched and can return to their original shape when released, and it has high elasticity properties. Example is known as natural rubber, synthetic rubber, styrene butadiene, SPR rubber, polyisoprene, and polybutadiene. We try to check the example of the question, so please check this question. This is known as thermoplastic, and here we have a cross-link. This is known as thermosetting, known as thermoplastic polymer, and when we see the cross link, this is known as thermosetting polymer, and this is known as elastomer. We try to check the question. Alright, state the type of polymer of each polymer P, Q, and R, and state its properties. So I present the answer in the table form. So plastic, a polymer P is known as thermoplastic, and its properties can be repeatedly remolded upon heating and can be recycled. Thermosetting polymer, the Q is known as thermosetting polymer. This thermosetting polymer cannot be remolded after heating and cannot be recycled. And the last one, R, is known as elastomer, can be stretched and can return to original shape when released and possess high elasticity properties. Alright, so next we move on to the polymerization reaction. Synthetic polymer are made through two types of polymerization reaction. Number one is known as addition polymerization. Number two is known as condensation polymerization. Addition polymerization reaction occur when the monomer that have double covalent bond between the carbon atoms C double bond C react with one another. During addition polymerization, the double covalent bond between the pair of carbon atom will breaks and form single covalent bond with the carbon atom from the nearby molecule, and they will combine together in repeating sequences, form long chain polymer. Addition polymerization reaction occur at high pressure, which is around 1000 atmosphere, and the temperature of 200 degrees Celsius. For example, take a look at the diagram. So this molecule C2H4 belongs to alkene homologous series, and the name of this monomer is known as ethene. When this ethene is combined in repeating sequences, they form long chain known as polyethene. For example of monomers that can undergo addition polymerization, so we call ethene, right? So we can use chloroethene and also styrene monomers, and these monomers will undergo polymerization, addition polymerization, and forming polyethene. All right, so ethene can undergo polyethene, and chloroethene will form polyvinyl chloride (PVC), and styrene can form polystyrene. And please try to check this diagram. All right, saying the polymerization, addition polymerization reaction, the monomer from alkene compound, the C double covalent bond will break and form single covalent bond. So this is the format that we have to write. The N is a very large molecule. The double bond will break, so the WXYZ can be represented with hydrogen, fluoride, chloride, or methyl compound. We try to check polyethene. How to draw the equation for the polyethene? When ethene molecule C2H4 undergo polymerization, we draw the structural formula. The structural formula of ethene molecule will be like this. So we try to cut the C double bond. So we put here C double bond, bonding. Make sure the site is empty. So we put bonding like this. So I open bracket and close bracket. I put N here. During addition polymerization, the C double bond, the double covalent bond will break and will form single covalent bond. All right, single covalent bond, we close the bracket, we put the N, we draw the structure like this. So this compound in monomer name is ethene, and the polymer name is known as poly. We take this one, we write here polyethene. So the answer is given here. I try to do for the polyvinyl chloride. The polyvinyl chloride, right, is known as chloroethene. So I try to draw the structural formula of the monomer ethene C2 All right, so we have this one, so C2H3. So here I put Cl, here is H. The structural formula of the monomer of chloroethene. So I cut the C double bond. I draw here C double bond. I cut bonding, 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 bonding. Make sure the side is empty. All right, so I take this structure. I draw here H. And I take this structure, I draw here the Cl, I put on the top, and this one I put here. So when we get this structure, we open bracket, close bracket, we put N. The C, during addition polymerization, the double covalent bond between atoms of carbon-carbon will break and form single covalent bond. Single covalent bond. We close the bracket, we put the symbol like this, and we put the symbol of N. This is the equation for the polyvinyl chloride, and this is known as chloroethene, and the polymer name will be vinyl chloride. Polyvinyl chloride, or we call PVC. And we try to check how to do the equation for the Perspex. The monomer name of Perspex. Okay, Perspex is known as methyl 2-methyl propanoate. Alright, I try to draw the structural formula of this monomer. I try to start with this one, methyl propanoate. This is known as ester compound. It has C double bond. So I write here C double bond, and here I draw the ester functional group of ester C double bond O. I take the methyl, I draw here. Alright, so each carbon must have 4 bonding. So this methyl, there's a branch present at carbon number 2, carbon number 1, carbon number 2. So here we have another branch. So I draw here. Alright, so next one I put H. Alright, so this is the structural formula of methyl 2-methyl propanoate. This we try to cut the C double bond. Alright, so after that we put bonding. So now I take this one, I put here H, and I take this one, I bring down. Alright, so this CH3 whole thing I put at the top of the carbon, and this chain, alright, so I make it CO2, and this one I make it CH3. Oh, this is the structural formula of the monomer of Perspex. So I put N here, so the monomer will undergo addition polymerization, so the double covalent bond will break and become single bond. Alright, so we draw the structural formula CO2 CH3. So we open bracket and close bracket, put the symbol of N here. We try to draw the structural formula like this. This is known as the Perspex polymer. Alright, the name of the monomer is known as methyl 2-methyl propanoate. Alright, so this is the structure, the equation that students should draw for the addition polymerization of Perspex, and try to practice on styrene, ethene. I already give answer in this module. Alright, and polypropylene. On to the next part. Another type of polymerization is known as condensation polymerization. Condensation polymerization involves combination of different type of monomers and removal of small molecule like water, ammonia, and hydrogen chloride molecule. Please remember, during condensation polymerization, removal of molecule like water molecule, alright, so ammonia molecule and hydrogen chloride molecule occur. Monomer in condensation polymerization have more than one functional group. Alright, so next one, the condensation polymerization produce terylene nylon. So we try to check the first example of condensation polymerization, which is nylon. Nylon made up of two type of monomer. When we see here 8, so please put decane diol. When we see 2 chloride atom, we put here dichloride. So the first monomer name is known as decane diol dichloride. And when we see here 6, we put 1,6 hexane. When we see 2 nitrogen atom combined in this structure, we put diamine. Alright, so another monomer is known as 1,6 diamine and decane dichloride. So the equation is given here. We try to practice the equation, how to draw the equation for the nylon. Nylon made up of 2 type of monomer. The first monomer is known as 1,6 hexane diamine. Alright, so I try to draw the formula for the 1,6 hexane diamine. So I put here CH2, close the bracket. I put 6 and nitrogen, hydrogen. I put the N symbol here. Plus with another monomer name is known as decane diol dichloride. So I try to draw the structure of formula of decane diol dichloride, so CH2. So I put here 8C double bond O Cl. So here C double bond O Cl. During then I put the symbol of N here. So during the condensation polymerization, removal of small molecule will occur where the hydrogen atom from 1,6x diamine will be removed and the chloride atom from the decanediol dichloride will be removed. Alright, so and we get the structural formula like this. So when we do the equation, we put here NHCl. Alright, so then we try to cut this structure. We draw here. Alright, so then we try to cut this structure. The whole thing we draw here. We combine with the monomer of 1,6 hexane diamine. Alright, so then we draw bracket. Then we put N symbol in front here. This is the polymer of nylons. Polymer is known as nylon. Alright, so the equation is given here. Try to practice and do more question. Another polymer that undergo condensation polymerization, please remember terylene. And this terylene is made up of two monomer. The first monomer is known as 1,2 ethane, ethane diol. Another monomer is known as terephthalic acid. Terephthalic acid. So these two monomer, please remember for terylene. Move on to the next part. We move on to the experiment to synthesis nylon and to study the properties of nylon. So in this experiment, we need 5% of decanediol dichloride solution and 1,6 hexane diamine solution, as well as the sodium hydroxide, hydrochloric, and also ethanol to wash the product form, and also acetone organic solvent to measure and to study the properties of nylon. So 50 cm power 3 of 5% of decan dichloride in cyclohexane solution is measured by using measuring cylinder. 50 cm power 3 of 5% of 1,6 hexane diamine solution is poured into the 10 drop of 6.0 mole Dm-3 of sodium hydroxide solution into the same beaker. The decan dichloride solution is poured slowly through the side of the beaker to allow to flow to the surface of 1,6 hexane diamine solution to reduce the formation of foam. The content of the beaker do not stir. The observation are recorded. The polymer film that is formed between the surface is pinched using forceps and pulled out slowly, forming a long rope. The nylon produced can be pulled out from the beaker slowly and winded on the measuring cylinder, or we can use glass rod. Okay, that is do not overlap. Step 6 is repeated until the nylon rope is pulled out. The nylon rope that produced form can be rinsed with 50% of ethanol followed by water to allow to dry. All right, once the observation whether the nylon drop break or not is recorded. All right, the nylon drop inserted in 3 test tube. Then we add 3 different solutions to study the properties of the nylon. First, hydrochloric acid. Second, sodium hydroxide. And the last solution is organic solvent acetone. All right, any changes on the nylon with the presence of acid, base, and also organic solvent are observed and recorded. So we need 1,6 dihexane diamine solution and decanediol dichloride solution. So we try to check the length of the nylon drop. It will form 18.5 meter like that. Okay, the color of the nylon is a white color. Nylon drop condition after stretching, it does not break. Nylon drop condition with the presence of concentrated hydrochloric acid, so the nylon drop will dissolve in concentrated acid, in concentrated hydrochloric acid. Next one, we go for the nylon rope condition with the presence of sodium hydroxide solution, no reaction, so it won't dissolve in the concentrated alkaline solution. Nylon drop condition in the presence of acetone, which is organic solvent. All right, nylon dissolve but very slowly. All right, so these are the properties that student will get when they do the experiment. So we move on to next part, try to do one structure question based on the formation of nylon through a polymerization reaction. So this experiment related to the condensation polymerization that did in the laboratory. The solution A will be diol dichloride solution, and solution A will be 1,6 hexane diamine solution. Try to answer the first question. State the meaning of polymer. Polymer is a long chain molecules made from combination of many small identical, identical, basic, basic units, units known as monomer, known as monomers. We try to check the second question. State the type of polymerization involved in the formation of nylon. That will be condensation. Condensation, polymerization. State the name of two solutions, solution A and solution B involved in the formation of nylon. So solution A will be 1,6 hexane, hexane diamine, diamine solution, and solution B will be decane, decane diol, diol dichloride, dichloride solution. Try to check question number D. All right, name the molecules that are removed during the combination of monomer stated in question C. So that will be hydrogen, hydrogen chloride, chloride molecules, hydrogen chloride molecules. State three properties of nylon that obtain from in this reaction. So nylon is white color, white color, non-toxic polymer. All right, so it is elastic, elastic, and also we can put very strong. These are the properties of nylon. All right, so we try to move on to the next part, the uses of polymer in daily life. All right, synthetic polymer are very stable, do not corrode or decay easily, and this polymers is known as biodegradable, degradable substance, and with the presence of water and also oxygen, all right, or other chemical substance or sunlight. Point number two, the presence of properties of synthetic polymer. They are chemically inert, light, hard, and strong. All right, and the second one, the C, point number C, all synthetic polymer is non-flammable, flammable, and they have low density, relatively cheap. All right, they are good resistance of heat. All right, so easy to mold or shape and can be colored. All right, so these are the properties of synthetic polymer. So I'll repeat again. They are chemically inert, light, hard, and strong, non-flammable, low density, relatively cheap, good resistance of heat, easy to mold or shape, can be colored. We move on to the next part, uses of polymer in medicine. Synthetic polymers such as polyethylene, polyethylene, polypropylene, or one more name we call polypropene. Polypropene are light but strong. They are used in making prostheses. Prostheses are the artificial leg or artificial hand devices that install in the outer body of the human to replace the part of all or missing body, all the missing body due to the illness or accident. All right, so next one, polypropylene. All right, polypropylene is also used to make personal protective equipment. Polyethylene terephthalate, PET, is used to make artificial arteries. Artificial arteries shown in the diagram below. All right, so this diagram is known as PPE suit. So PPE suit is made up of polypropylene. So polypropylene, the monomer name is known as propene, and the molecular formula C3H will be 6. And type of polymerization is known as addition. Addition polymerization. And how to do the chemical equation. So we draw the structural formula of propene. So here got double bond. Each carbon must have 4 bonding. All right, so each carbon must have 4 bonding. So I cut the C double bond. I write down here C double bond bonding on the top and bottom. All right, I take the H, I put here. I take this H, I put at the bottom, this H on the top, and this whole thing I make it CH3. Then I open bracket, close bracket, we put N. Right, so during addition polymerization, the C double bond covalent bond will break and form single covalent bond. So the structure we follow exactly like monomer. All right, so we open bracket, we close the bracket, we take the symbol and we put here. So we draw like this. So this is the chemical equation for the formation of polypropylene, and the type of reaction is known as addition. Addition polymerization. All right, so we move on to the next part. We check the uses of polymer in textile industry. So it's used to make fishing line, the polymer that used to make fishing line, parachute, clothes, and socks, that will be under nylon. All right, so next one is used to make clothes, sail clothes, and parachute. This type of polymer is known as terylene. Please remember this nylon, nylon and terylene. Terylene is a polymer that formed through condensation. Condensation polymerization. All right, so next one under safety. So we have this polymer is used to make bulletproof vest, uniform of firemen, helmets of soldier. All right, so this polymer is known as Kevlar. Kevlar polymer, and because of it heat resistant and also strong properties. So this is made up of Kevlar polymer. All right, so the point number 2 is used to make electrical switch cookware handle because of its good electrical and heat resistant or heat insulator. And this type of polymer is known as Bakelite. And please remember, this Bakelite is example of thermo setting polymer. All right. So we move on to the next part, undercoating. So undercoating, we will have a non-stick cookware is made up of Teflon. Please remember Teflon. Right, Teflon is made up of the monomer name of the Teflon is known as tetrafluoroethene. All right, so the structural formula of tetrafluoroethene, so we have C2, we put here 1F, difluoro, and tetrafluoroethene. So we open bracket, close bracket, we put N symbol during addition. Polymerization, the C double bond will break and form single covalent bond. So it will form long chain polymer known as Teflon. This is the chemical equation that students should write if they ask in the question exam. All right, so next one, under packaging. Under packaging, polyethylene and also polypropylene. Polypropylene are used to make food packaging. Another one is also used to make food packaging container, electrical goods, disposal, cup and container. This will be under polystyrene. All right, so we check few example of polymer, monomer, and their uses. So this polymer is used to make our aeroplane window, car light cover. The name of the polymer is known as Perspex. The Perspex of Perspex will be methyl to methyl propanoate. All right, next one, manufacture of conveyor belt, wetsuit, small boat, elbow support. This will be under neoprene. The name of the polymer is neoprene. The monomer name of neoprene is known as chloroprene. All right, so next one, under manufacture of tire, soles of shoes, we will use styrene butadiene, or we call SBR rubber. So the monomer of styrene butadiene is known as styrene and also butadiene. All right, next one, under plastic bag, shopping bag, container, toys, this will be under polyethylene and the monomer name will be ethene. Okay, pipe, rope, carpet, plastic chair, plastic bottle, plastic container, this will be under polypropylene and the monomer name is known as propylene. Water pipe, raincoat, electrical insulator, artificial seat or mat, this will be under polyvinyl chloride. The monomer name of polyvinyl chloride is known as chloroethene. All right, so these are the uses of polymers and their monomers that student must remember. So dear student, we try to do a question, essay question related to the condensation polymerization and also addition polymerization. Look at the question. The polymer are widely used in our daily life. The diagram 10 shows the two different polymer A and polymer B. Polymer A is used to produce thread. They are important in textile industry. Therefore, this polymer is known as nylon. This nylon is produced through condensation polymerization. All right, so we check polymer B. Polymer B is widely used in making plastic packaging. All right, so this polymer is known as polyethylene. All right, and this one is known as polypropylene. Type of reaction undergo by this polymer B is known as addition polymerization. All right, so we try to check the question. They want the meaning of polymer. Give one example of natural polymer. Draw the structural formula and name of polymer B according to IUPAC system. All right, so we try to do the answer. So polymer is a long chain molecule made from combination of many repeating basic unit known as monomers. All right, so second requirement of the question, they want us to give one example of natural polymer. So example of natural polymer, we can use natural rubber, or we can put polyisoprene, or we can use protein. This one, name the monomer B. So they want the name of the monomer B, so I'll take the polyethylene, so I write here polyethylene. All right, second question, they want the structural formula of polymer B, so we write the structural formula of polyethylene. So I'll write C single bond, so we put H here, we put H here, we open bracket, we close bracket, we draw symbol like this, when we put N. This is the structural formula of polymer B. In question, we try to check second question. Compare and contrast polymer A and polymer B in terms of type of polymerization reaction, characteristic of the monomer involved in the reaction. So when we compare and contrast, we try to give one similarity. The similarity both polymer A and polymer B is known as synthetic polymer, and polymer A and polymer B are known as biodegradable polymer. All right, so we try to go for comparison. So I present the answer in the table form. Type of polymerization reaction. So polymer A undergo condensation polymerization, while polymer B undergo addition polymerization. The characteristic of monomer involved. They want the characteristic of monomer involved. The characteristic of monomer in condensation polymerization have more than one functional group or more than one homologous series. All right, so then for the addition polymerization, the monomer has double covalent bond between two carbon atom. All right, so then we move to the next part, the polymer and the environmental effects of this synthetic polymer waste. All right, some polymers, they are known as stable and take long time to disintegrate. This causes serious pollution problem. The stable properties of synthetic polymer make them useful, but at the same time difficult to be disposed due to their non-biodegradable properties. All right, so we try to check the environmental impact on the land. The waste synthetic polymer that are biodegradable has caused blockage to our drainage system, and this can cause flash flood. All right, so we move on to the next point, the plastic. The plastic container that are not disposed properly become breeding ground for mosquito and can cause the spread of diseases like dengue and malaria. All right, so we move on to the next environmental impact on the water, the synthetic polymer waste or the plastic polymer waste. Waste contaminate the lake and river and causing the water not suitable for aquatic living things, and this synthetic polymer waste also can alter the pH value of water and can kill the aquatic living things. All right, point number 2, marine pollution causes marine creatures to be die, and the microplastic or tiny plastic to enter the food chain. All right, so third one, we go for the environmental impact to the air, the burning of synthetic polymer waste openly release toxic gases that are pungent, acidic, and also poisonous, which can contaminate the air and can cause greenhouse effect and also acid rain. So the point number 2, the raw material for making synthetic polymer is known as petroleum. This petroleum is diminishing and also non-renewable sources of energy. All right, so now we move on to the ways to overcome the pollution problem causing by the synthetic polymer waste. In line with the advanced science and green technology, various methods has been introduced to ensure more sustainable use of polymer. Our first method is known as reuse of synthetic polymer and recycle the synthetic polymer, and use of biodegradable or degradable synthetic polymers. All right, and the last one, we burn the synthetic polymer waste in closed furnace, where the gas are filtered, substance are absorbed before we discharge into the air. All right, so we try to check the point number 3. Point number 3, recycling. Recycling and reuse is the easiest way for the consumer to ensure the synthetic polymer do not end up in the landfill. The plastic can be decomposed by eating them without the presence of oxygen at the temperature of 700 degrees Celsius, and this process is known as pyrolysis process. All right, the product of this process are then recycled into new product. The introduction of biodegradable polymer, particularly for the plastic product, enable pollution to be reduced, and the polymers are mixed with additive such as starch, cellulose, xanthan, and that can be decomposed by bacteria to become biodegradable or decomposed by light, and this is known as photodegradable. All right, so the synthetic polymer waste can be burned in closed furnace, and the toxic gases are filtered and absorbed before we discharge into the air. Alright, these are the environmental problem caused by the synthetic polymer waste and the way to overcome the problem using the causing by the synthetic polymer waste. Alright, so we move on to the next example of the question. This student try to look at this question, paper 2 section A structure question. So in this question, the table shows the example of the product of polymerization process. We have polymerization A and polymerization B. The polymerization A produce nylon and this is polyvinyl chloride. Alright, so we try to check the questions. Name the type of polymerization A. The polymerization A is known as condensation polymerization process. B, the polymerization, the polyvinyl chloride is made through addition polymerization process. All right, so we try to go for the question number B. State the three properties of nylon. The nylon is known as strong, all right, strong, elastic, all right, and also non-toxic polymer. All right, so we try to check the question number C. Name the monomer of polyvinyl chloride. The monomer name will be chloroethene. Alright, so next draw the structural formula of the chloroethene. So we put C double bond. So we put bonding. So I put here H hydrogen atom and chloride atom. This is the structural formula of chloroethene. Alright, so now we try to go for question number D. Write the chemical equation to show the polymerization of polyvinyl chloride. So we try to draw the structural formula of chloroethene, C double bond C. So we put hydrogen atom. So here hydrogen atom, and chloride atom. We open bracket and close bracket and we put N symbol. Alright, so this chloroethene will undergo addition polymerization where the C double covalent bond will break and form single covalent bond. Alright, so we put here Cl, we open bracket, we close bracket, we put the N symbol, so we draw structure like this. Alright, this is the chemical equation for the polymerization of polyvinyl chloride. Alright, so now we move on to the question number E. Alright, so state the effects of improper disposal of synthetic polymer waste on the environment. So we try to check the point number 1, the plastic waste that made up of synthetic polymer that are non-biodegradable can cause blockage to our drainage system and this can cause flash flood. All right, so next point, the plastic container that are not disposed properly become breeding ground for mosquito and can cause the spread of diseases like dengue. All right, so the point number 3, the plastic waste contaminate the lake and river with chemicals causing the water is not suitable for aquatic living thing, and this also can cause marine pollution. All right, so we try to go for question number C. Suggest suitable ways to overcome the pollution problem from using the synthetic polymer. So we try to suggest the number of ways to overcome the pollution problem from using synthetic polymers. The first one will be reuse the synthetic polymer waste, and next one will be recycle the synthetic polymer, and the third one, use of biodegradable or degradable synthetic polymers. All right, and the fourth method will be burn the synthetic polymer waste in closed furnace. All right, so these are the methods that we can use to overcome the pollution problem caused by the synthetic polymer waste. All right, so we try to elaborate the first point. All right, recycling and the reuse is the easiest way for the consumer to ensure the synthetic polymer do not end up in landfill. The plastic can be decomposed by eating with them without the presence of oxygen at the temperature of 700 degrees Celsius, and this process is known as pyrolysis process. The product of this process are then recycled into new product. All right, so next one, the introduction of biodegradable polymers, particularly for the plastic products, enable the pollution to be reduced. The polymers are mixed with additive such as starch, cellulose, right? Cellulose that can be decomposed by bacteria to become biodegradable or decomposed by light. All right, so these are the answers that student can write. All right, so we move on to the next question. All right, try to look at this question. All right, so they are given few example of a product made up of synthetic polymer or natural polymer. The first one is rubber. All right, next one is polyethylene, polyvinyl chloride, and starch. All right, so we need to classify the polymers shown in diagram 7.1 into natural polymer and also synthetic polymer. All right, so please remember this is made up of tire. Tire is known as SBR. SBR rubber, styrene butadiene rubber. So this is known as synthetic polymer. Alright, polyethylene also is synthetic polymer. Polyvinyl chloride also synthetic polymer, and this is known as natural polymer. Starch is made up of natural polymer, so the answer will be starch. Alright, so here I put rubber, or we can write tire. Alright, so next one, polyethylene. Alright, polyethylene is a synthetic polymer, and the next one will be polyvinyl. Polyvinyl chloride also is a synthetic polymer. And draw and state the name of monomer of polyethylene. The name of monomer of polyethylene is known as ethene. Alright, and we need to draw the structural formula of the monomer of polyethylene. So we draw C double bond, bonding. So I put hydrogen atom. This is the structural formula of monomer of polyethylene. Alright, so now we try to check the question, objective question. Alright, so diagram shows the structural formula of compound Z, okay, is which used to make a pipe. Alright, so they use polyvinyl chloride. So this is known as PVC pipe. Alright, so what is the advantage of using this pipe? This pipe is do not corrode. Alright, does not corrode. Alright, so the suitable answer will be D. Alright, so we move on to the next question. Alright, next question. Which substance is known as natural polymer? This is synthetic polymer, polyvinyl chloride, synthetic polymer. Please remember another name for natural rubber is known as polyisoprene. The polyisoprene is a natural polymers. Alright, so next one. So we try to check which pair of monomers and polymers is correctly matched. Methyl methacrylate is known as Perspex. Alright, so next one, chloroethene. Chloroethene is the polymer name is PVC. Alright, so the answer will be C. Isoprene will be polyisoprene, natural rubber. Propene will be polypropene. So the answer is B. Try to discuss essay question. So look at this question. One of the uses of polymer is used to make plastic bottle. Shown the diagram 7.2 shows the modification of a plastic bottle. Alright, so we try to check the question. Improper disposal of plastic bottle can cause pollution. Based on the diagram 7.2 and the pollution issues faced by our nation, justify the use of polymer and give another example. So here the plastic bottle has been modified as to the was. Alright, so we try to answer this question. So how to answer this question? I try to check with the standard answer. Alright, plastic bottle made up of synthetic polymer which are biodegradable. Right, non-biodegradable, and these plastic bottles are stable and take longer time to disintegrate that can cause serious environmental problem. Alright, so we try to check for the land. The plastic waste that made up of synthetic polymer that are non-biodegradable can cause blockage to our drainage system, and this can cause flash flood. Alright, so next one, the plastic containers that are not disposed properly can become a breeding ground for the mosquito and can cause spread diseases like dengue. Alright, so we go for environmental impact to the water. Alright, so this plastic waste, or we can put synthetic plastic waste contaminate the lake and river with chemicals causing the water not to be not suitable for aquatic living things. And next point, marine pollution causes many marine creatures to die, and the microplastic to enter the food chain. Alright, so the environmental impact to the air, the burning of synthetic plastic waste openly release toxic gases that are pungent, acidic, and also poisonous, which can contaminate the air, and this can cause greenhouse effect and also acid rain. Alright, so in line with the advanced science and green technology, various methods has been introduced to ensure more sustainable use of polymers. One of the method is reuse. We can use reuse or recycle the plastic waste. So we need to give another example. So we try to give another example. The plastic are used to make decorative vase or plastic boats. Alright, to the second essay question. Try to look at this question. The diagram 7.3 shows the use of plastic bag in daily life. Alright, this plastic bag is made up of polyethylene, and the monomer name of this plastic bag is known as ethene. Alright, ethene undergo addition, polymerization. Alright, so we try to check the question. The plastic bags are polymer material that are most disposed of in Malaysia. Comes effects of plastic pollution to the environment. Explain how to overcome ensure more sustainable use of polymers. Alright, so try to answer this question. In line with the advanced and science green technology, various methods has been introduced to ensure more sustainable use of polymers. The ways are reuse, recycle. Alright, so the use of biodegradable polymers, or biodegradable, or photo photodegradable synthetic polymers. Alright, and the fourth method will be we burn the synthetic plastic waste in close furnace. Alright, these are the method we can use to prevent or to overcome the pollution problem. Alright, so we need to explain the point in detail. So first one, recycling and reuse is the easiest way for consumer to ensure the plastic synthetic polymer do not end up in the landfill. The plastic can be decomposed by eating them without the presence of oxygen at temperature of 700 degrees Celsius. So this process is known as pyrolysis process. The product of this process are then recycled into new product. The introduction of biodegradable, particularly for the plastic product, enable the pollution to be reduced. The polymers are mixed with additives such as starch that can be decomposed by bacteria to become biodegradable or decomposed by light. The synthetic plastic waste can be burned in closed furnace, and the toxic gas are filtered and absorbed before we discharge into the air. All right, so this is how we answer the essay question. So we move on to the next part. We try to check this question. So diagram 1 shows the raincoat. All right, so this raincoat is made up of polyvinyl chloride. All right, the first question state the monomer name of polyvinyl chloride. So that will be chloroethene. And draw the structural formula of the monomer of chloroethene. So we draw C double bond C. We put bonding. So here we put hydrogen atom, and chloride atom. So this is the structural formula of the monomer of chloroethene. And this monomer of chloroethene will combine in repeating sequences and form long chain known as polyvinyl chloride. And the name of the process X, where the monomers combine and form polymers, is known as addition polymerization. Check question number B. State one advantage of using polyvinyl chloride as water pipe compared to the metal pipe. Alright, so this polyvinyl chloride has high resistance towards corrosion. So we put resistance to corrosion. Alright, now we try to go for question number C. State one reason why polyvinyl chloride should not be disposed by open burning. So this open burning of polyvinyl chloride can release toxic gases, which is poisonous and also acidic and pungent smell. So this can cause various environmental pollution like greenhouse effects, acid rain, like that. All right, so we move on to the next question. I try to check this question. Diagram 3 shows the object made up of plastic, and all this plastic is hard and also strong. All right, so we try to check question number A. State the type of plastic X. So this will be under thermo setting plastic or thermosetting polymer. State two example of plastic X. So this will be bakelite and melamine. Alright, state the two characteristics of plastic X. So this plastic X cannot be remolded. Alright, and also cannot be recycled. Alright, so these are the characteristics of thermosetting plastic. Alright, now we try to check question number D. Draw the structure of plastic that cannot be removed and recycled. So how to draw? So we draw like this. Alright, and we move on to the next part under natural rubber. We try to investigate the properties of natural rubber, how the natural rubber is formed, and the properties of natural rubber, how to hardening natural rubber in this subtopic. Alright, so natural rubber is known as natural polymer. The point number 2, the natural rubber is derived from bark of rubber tree, and this is colloidal liquid. It's a milk obtained from the bark of rubber tree. Latex is a colloid mixture of water and rubber particles polymer. Latex is a colloidal mixture of water and rubber particles polymer. The formula of natural rubber is C5H8 and N is by a large molecule, about 10,000 molecule. Alright, so this natural rubber will undergo addition polymerization occur to combine thousands of isoprene. The monomer name of natural rubber is known as isoprene. Alright, so thousands of isoprene unit to form polyisoprene or natural rubber. The monomer of natural rubber is known as isoprene, or another name is known as 2-methyl but 1,3 die in. And how to draw the monomer of natural rubber? So the monomer of natural rubber is known as 2-methyl both 1, 3 die in. So we try to check both and it has 2 double bond. So it has 1, 2, 3, 4 and 4. Alright, so the double bond, 1 double bond present at carbon number 1 after carbon number 1, carbon number 2, carbon number 3, carbon number 4. Alright, so after carbon number 1, I put 1 double bond and another double bond present after carbon number 3. So here is another double bond. Alright, so carbon number 2, we have branch. So at carbon number 2, we put 1 branch CH3 methyl. Alright, each carbon must have 4 bonding. So I put here hydrogen atom, hydrogen atom. So here hydrogen atom. This is the structural formula of the monomer of natural rubber. And this is known as structural formula of monomer of natural rubber. Another name of this monomer is known as isoprene. Alright, so when these monomers undergo addition polymerization, so it will form long chain known as natural rubber. How to do the addition polymerization equation for polyisoprene? So we cut all this. Alright, so we write down here C double bond, C single bond, double bond, alright, carbon. Alright, so each carbon, so we put bonding here, bonding here, bonding here. Alright, on the top of I carbon, we put bonding, bonding, bonding. Alright, so I take this atom, hydrogen atom, I put here. I did bring this hydrogen atom to the down. Alright, so this whole thing, I make it here CH3, and this hydrogen atom, I put here, this one I put here, and this one I bring down. Alright, so we open bracket and close bracket, we put N. Right, monomer of natural rubber, so we draw like this. Alright, so here's double covalent bond, we make it single. Here single covalent bond, we make it double. So I put double here. Here double covalent bond, we make it single covalent bond. And the rest we follow like what we see in monomers. So hydrogen, so here put hydrogen, here CH3, here hydrogen. Alright, so here I put hydrogen, here I put hydrogen. So I open bracket, close bracket, put the symbol of N is here. So I draw structure like this. Right, so polymerization equation to form polyisoprene or natural rubber. Move on to the characteristic of natural rubber. The characteristic of natural rubber depend on the rubber polymers that are natural elastomeric. Natural elastomeric polymers. The natural rubber exists as soft and white solid at room temperature. The first characteristic, the soft white solid at room temperature, this shows that natural rubber is known as less elastic. Alright, second one, natural rubber can be stretched and can return to its original shape when we release. Alright, so this is belongs to elastic. This shows the natural rubber is elastic. Alright, so we go for third point. Alright, third point, at high temperature, natural rubber will become sticky and also soft. This shows that natural rubber less resistant to heat. Alright, we move on to the fourth point. Natural rubber cannot conduct electricity and is a good electrical insulator. Therefore, natural rubber is known as electrical insulator. Alright, so we go for point number 5. Oxygen in the air can react with double covalent bond between the carbon atoms and causes the natural rubber to be oxidized. That means the proper characteristic of natural rubber is known as less resistance to oxidation. Right, natural rubber is less resistance to oxidation. And point number 6, react easily with acid, alkali, and also organic solvents. So this causes natural rubber cannot withstand chemical reaction. Alright, so last point, natural rubber is water impermeable, and this is known shows the natural rubber insoluble in water. Alright, so we try to move on to the characteristic explanation for each characteristic of natural rubber. First characteristic will be natural rubber is elastic. So when the natural rubber polymers are entangled or stretched, the polymer chain will straight out. When we release the pressure, the polymer chain can revert back to the tangled state. So how to explain this process? So in a normal condition, the polymer chain of rubber folded until they become entangled. When the natural rubber is stretched, the natural rubber polymer chain are straightened and the rubber become elongated. Alright, when the force is released, the polymer chain return to their original tangled state. Alright, so we go for next characteristic of natural rubber, which is natural rubber has low resistance toward heat. The natural rubber is heated. When the natural rubber is heated to temperature above 60 degrees Celsius, it will melt. It will melt and become sticky. Alright, so the heating of temperature to a temperature above 200 degrees Celsius will decompose the rubber. Then the natural rubber is cool, it become hardened and brittle. brittle like a plastic. All right, so we go for characteristic number 3. The natural rubber can be oxidized, easily oxidized. The natural rubber is less resistant to oxidation. All right, we go for point number 2. The presence of double covalent bonds in the polymer chain of rubber causes the rubber to undergo oxidation easily. Oxygen and water in the atmosphere with the presence of ultraviolet rays. All right, ultraviolet rays can oxidize the natural rubber and decompose it gradually. All right, so the topic number 4. The natural rubber does not dissolve in water but dissolve in organic solvent. The rubber polymer is composed of a long chain of hydrocarbon bonded together through covalent bond. Okay, thus the rubber polymers insoluble in water and does not allow water to pass through. All right, so the natural rubber dissolve in organic solvent like tetrachloromethane solution CCl4, petrol carbon disulfide, and chlorohydrocarbon solution. Right, so we go for the uses of natural rubber. The natural rubber is used as electrical insulator for electrical appliance and cables, material to increase frictional force such as floor mat, soles of slippers, and rubber door stopper. All right, so the third uses of natural rubber. Rubber is also used to make rubber tube, rubber cover, and rubber band. All right, glove. All right, so we try to look at the question. The question, by using suitable diagram, describe the coagulation of latex. The coagulation of latex means the liquid latex is changing into solid rubber. Okay, and this process is known as coagulation of latex. How to describe the coagulation of latex? First, we try to draw the diagram of rubber particle. So I put one circle. So the rubber particles are made up of protein membrane. So this is known as protein membrane, and inside here we have rubber polymers. All right, so this is known as rubber polymers, and the surface of rubber polymers is negatively charged, and this is known as rubber particles. So how to explain the first diagram? All right, so latex is an aqueous suspension colloidal rubber particles. Okay, each rubber particles consists of rubber polymers that are surrounded by a layer of protein membrane. All right, the surface of protein membrane are negatively charged. All right, so we try to go for a second diagram. So I draw two rubber particles. All right, with the protein membrane, and the surface of protein membrane are negatively charged. All right, so here I put negative charges. All right, so please remember, like charges or the same negative charges on the that present on the surface of protein membrane causes repulsion. So here it causes repulsion between the rubber particles. So here we put rubber particles. All right, so how to answer this? We explain this diagram. So the negative charges, okay, on the surface of protein membrane causes the rubber particles repel each other. This prevent collision. This prevent collision of rubber particles and hence prevent the coagulation of latex. All right, so we go for fourth diagram. We try to add a chemical substance like metanoic acid or formic acid, which contains hydrogen ion to neutralize the negative charges that present on the surface of protein membrane of rubber particles. So we try to draw the rubber particles. So inside here we put rubber polymer. So we try to put negative charges present on the surface of protein membrane. So when we add metanoic acid, the hydrogen ion from the metanoic acid will neutralize the negative charges that present on the surface of protein membrane. All right, so we try to go for point number F. Metanoic acid or formic acid is added to the latex. So the hydrogen ions from metanoic acid will neutralize the negative charges present on the surface protein membrane. The neutral rubber particle is formed. All right, so the neutral rubber particles will do what? They will collide each other. Therefore, we draw two rubber particles, neutral rubber particles. All right, so here we put neutral rubber particles. These neutral rubber particle will collide each other. All right, so the next point, the neutral rubber particles will collide each other. So when during the collision between the neutral rubber particles, the protein membrane will breaks. All right, so break up, and the rubber polymers will start to coiling by combining together to form large lump. All right, so thus the latex coagulated. Right, that's how we explain the coagulation of latex by using example of diagram. All right, so we move on to the next part. Then we try to investigate the coagulation of latex and method to prevent the coagulation of latex. So look at the question given in the module. So diagram 2 shows the fresh latex produced from the rubber tree and coagulated latex transformed to the rubber strip. Right, so we try to check the question. So diagram plan and laboratory experiment to investigate the effects of acid and alkali on the coagulation of latex. So what we try to do the experiment in the laboratory, we measure and pour 100 cm power 3 of latex. All right, latex in a beaker. All right, so we try to take a suitable acid. So in the laboratory, we will take ethanoic acid. When we add the 5 cm power 3 of ethanoic acid, so we try to stir the mixture with the latex with the ethanoic acid. So what will happen? The latex will coagulated. All right, so when we will be ammonia solution will be added to the latex. So when we take ammonia solution NH3 with water, so it will ionize to produce ammonium ion, neutral ion, and hydroxide ion. This hydroxide ion will add more negative charges to the rubber particles, and it will ensure the rubber particles always repel each all the time, and it also will provide alkaline medium and kill all the bacteria which can produce lactic acid. All right, so this will ensure the latex in liquid form will remain as a liquid form and will prevent the coagulation of latex. So how to describe this experiment? The problem statement does acid and alkali. So here effect we change it to effect on the coagulation of latex. Then we put question mark. All right, so the manipulated variable will be the presence of acid and alkali. So here we will put ethanoic acid and ammonia solution. All right, the responding variable will be coagulation of latex, and constant variable. The constant variable we will make sure the volume of ethanoic acid. All right, ethanoic acid, the volume of latex, and also the volume of ammonia solution remains the same for all experiment. All right, so next one, how to do the hypothesis when ethanoic acid is added to latex, coagulation occur, and when ammonia solution is added to latex, it will prevent the latex from coagulating. All right, so we try to check the apparatus. We need beaker, glass rod, measuring cylinder. We need latex, ethanoic acid, and ammonia solution. So the first procedure will be we try to measure and pour. All right, the first point, measure and pour 100 cm power 3 of latex into a beaker, 5 cm power 3 of ethanoic acids into the same beaker. The mixture need to be stirred. So we stir the mixture by using glass rod. Observe and record the changes that occur to the latex. Repeat step 1 until step 4 using ammonia solution to replace ethanoic acid. So the tabulation of data, so we put here experiment. So the first experiment we conduct with latex added with ethanoic acid. So here we put observation. The observation will be latex coagulated very quickly. All right, so next one we try to check added latex is added with ammonia. When we add ammonia solution into latex, it will prevent the latex from coagulated. So the observation, the latex does not coagulated. The latex does not coagulated. So this is the experiment that student must remember to prevent latex for the coagulation of latex and the method to prevent the coagulation of latex. All right, so next part we try to check the vulcanization process in order to strengthen or harden the natural rubber. So vulcanization is a process of forming sulfur cross links. Sulfur cross links between the polymer chain of natural rubber molecules to produce rubber that is more elastic and better properties or better quality than the natural rubber. The rubber is heated with the sulfur in the presence of catalyst zinc oxide at the temperature of 140 degrees Celsius. So when we take a natural rubber, or we call unvulcanized rubber, added with sulfur atom in the presence of zinc oxide at the temperature of 140 degrees Celsius, so we will get vulcanized rubber, and this process is known as vulcanization of rubber. It is known as natural rubber The natural rubber does not contain sulfur crosslink. When we heated with sulfur atoms in the presence of zinc oxide at the temperature of 140 degrees Celsius, all right, so the sulfur crosslink will form between the rubber polymers. All right, the vulcanized rubber can be prepared in laboratory by chalking the rubber in the solution of disulfur dichloride solution, or we can take another one, sulfur monochloride solution. So please remember these two solution, all right, for the objective question. All right, so the sulfur atom with the double covalent bond in rubber molecules change to form sulfur cross links between the rubber molecules or rubber polymers, so that the vulcanized rubber has many sulfur cross link between the rubber molecules. All right, so the how to draw the vulcanized rubber molecules. So all right, we draw another rubber polymers. I try to go for another rubber polymer. So once we already draw this rubber polymers, so we try to add sulfur atom. So here I put two sulfur atoms. They will form crosslink. So here at the bottom, I put two sulfur atom. Here I put two sulfur atom. So here I put two sulfur atoms. All right, so this is the crosslink of a sulfur crosslink that form between the rubber polymers. So I try to label this is sulfur cross link. Right, so this is known as rubber polymers. So that's how we draw the sulfur crosslink that form in the vulcanized rubber. All right, so we try to go for the experiment to prepare vulcanized rubber in laboratory. All right, so we need a latex solution. All right, we need the material that needed is latex solution, ethanoic acid, and sulfur dichloride solution. So we need a beaker, dropper, white tiles. All right, so clip, knife, measuring cylinders, glass, rod. All right, so first we coagulate the latex by adding ethanoic acid. So the first procedure, measure 25 cm powder of latex by using measuring cylinder and pour into a beaker. Add 5 drops of ethanoic acid using the dropper and stir the mixture. These two steps will coagulate. All right, will coagulate the latex. So third procedure, pour the latex into the white tiles and spread it over using glass rod. The rubber on the white tiles is left dry for a few days. The rubber strip is cut to produce rubber strips of same size. One of the rubber strip is dipped into disulfur dichloride solution or sulfur monochloride solution for 5 minutes. Both rubber strip are L and press. All right, so the observation is recorded. So that's how we prepare the vulcanized and unvulcanized rubber. So we try to check the properties of vulcanized rubber, natural rubber, and also the rubber that we chalk in disulfur dichloride solution. So the observation will be the natural rubber that it will be soft, less elastic, and not strong. And the second one, the rubber strip that chalk in disulfur dichloride solution is hard, more elastic, and strong. All right, so we try to go forward to investigate the elasticity of vulcanized rubber and unvulcanized rubber. So please remember this unvulcanized rubber is natural rubber, and this rubber is less elastic than vulcanized rubber. All right, so we try to check the conversation between the two person, between Chegu Zul and also with the student. All right, so plastic are more elastic. So here they give rubber band, and also here they give tire. All right, here they give tire. All right, so the which product is more elastic? So according to this student, tire is more elastic, and this student also agree with the Zul. All right, so we try to check the question. All right, so referring to the diagram, plan, and laboratory experiment to investigate the elasticity of vulcanized and unvulcanized rubber, your planning should include following aspect: problem statement, all the variables, statement of hypothesis, list of materials and apparatus, procedure, and tabulation of data. For this experiment, we will try to do experiment like this. So we will take a retard stand. We will measure we will use a natural rubber strip. We will try to take the initial length 5 cm or between 5 to 10 cm, and we will try to hang a weight, all right, weight of 50 gram to 100 gram, and we will try to measure the elasticity of this rubber strip. And the next one, we will repeat the experiment by using vulcanized rubber. All right, so how to explain the problem statement? Does vulcanized rubber is more elastic than unvulcanized rubber? Make sure we put question mark here. So the manipulated variable will be type of rubber strip. All right, so next one, the responding variable will be the elasticity of vulcanized and unvulcanized rubber. All right, unvulcanized rubber strip. All right, so next one, the constant variable initial length of rubber strip or the mass of weight. All right, so the hypothesis will be vulcanized. Vulcanized rubber is more elastic than unvulcanized rubber. So the apparatus, meter ruler, 50 gram of weight, clip, retort stand with a clamp, and also scissor. So vulcanized rubber strip or unvulcanized rubber strip. All right, so we try to measure and cut the rubber, vulcanized rubber about 10 cm or length, record the initial length of the rubber strip, clamp the rubber strip on the retort stand. We try to hang 50 gram of weight at the end of the vulcanized rubber strip by using clip. Measure and record the length of vulcanized rubber strip after it being stretched. Remove the weight and record the length of rubber strip. We want to see whether it's returned to its original length or not. Repeat step 1 until step 6 using unvulcanized rubber strip to replace vulcanized rubber strip. Try to check the tabulation of data. So here we put what type of rubber, vulcanized and unvulcanized rubber, the length of rubber strip before the weight is hanged and after the weight is removed. Then we try to check the extension of rubber strip. Let's say before the weight is removed 10.0. Right here also 10.0. After the weight is removed, vulcanized rubber able to return to its original position. So it able to retain to its original position. So the extension will be 0.00. No extension occur. But one unvulcanized rubber is less elastic. Maybe after the weight is removed, maybe it's unable to return to its original length. So maybe 13.0. So the extension is 3.0 cm. Try to look at this essay question. The diagram 7.1 shows the flow chart of situation when the latex is collected from the rubber tree and is used to produce rubber type A and also rubber type B in laboratory. All right, so here the latex at the laboratory bring to the chemical laboratory. They do process 1. All right, the latex from the rubber tree. All right, then the process 2, the rubber has been changed into from liquid. All right, liquid it changed to solid. So here they add methanoic acid. All right, so this is process 2, coagulation of latex. This prevent the coagulation of latex. All right, so here they take process 3. Process 3, the rubber type A is chopped in disulfur dichloride in methyl benzene. So this process is known as vulcanization process, and process 2 is known as coagulation. All right, coagulation of latex, and this process is known as prevent the coagulation of latex. So they add ammonia solution. So this process is prevent the coagulation of latex. All right, so we try to check the question. So question number 1 suggests a substance that should be added in process 1, that will be ammonia solution to ensure the latex remain as a liquid, okay, until it be taken to the chemistry lab. All right, so state the name of rubber strip A and also rubber strip B. All right, so the substance that added in process 1 is known as ammonia solution. All right, so rubber strip A. So rubber strip A is known as natural rubber, or we can use unvulcanized rubber. This rubber is used to make glove, all right, rubber band, all right, so all that, door stopper like that. All right, so rubber type B is known as vulcanized rubber. It has been chopped with disulfur dichloride process and undergo vulcanization process. All right, we try to go for question number 2. All right, we go for question number 2. All right, compare tire A and tire B in terms of hardness. They want us to compare in terms of hardness, elasticity, resistance to heat, resistance toward oxidation. Explain why rubber B is more suitable to make a tire compared to rubber A. All right, so I try to present the answer in table form. So here I put rubber A is unvulcanized rubber, rubber B is vulcanized rubber. Hardness, this is soft and hard. Elasticity, less elastic, more elastic. All right, resistance to heat. Rubber type A is melt easily when heated. Rubber type B hard to melt and can withstand high temperature because this is known as vulcanized rubber. All right, so we go for all resistance to oxidation. Rubber type A, unvulcanized rubber, easily oxidized by oxygen, thus is less resistance toward oxygen. Rubber type B, not easily oxidized by oxygen, thus more resistance towards oxidation. All right, go for last question. Explain the why rubber type B is more suitable to make tire compared to the rubber type A. So explain why rubber type B is more suitable to make a tire compared to rubber type A. So how to answer this question? So rubber type A, B is more suitable to make tire. The presence of cross-linkage of sulfur between the rubber polymer in rubber type B prevent the rubber molecules or rubber polymers from sliding over each other. Okay, thus the rubber type B is more elastic and can withstand high pressure than the rubber type A. All right, so rubber type A is soft, sticky, easily change its shape when high heat and pressure is applied. All right, so that's how we explain the essay question which carries 10 marks. All right, so we move on to the next part. Then we try to do one structure question. Look at this question. Diagram 1 shows the observation, two observation for the condition of latex when substance P and substance Q is added. So when substance P is added to the latex, latex coagulate. When substance Q is added, the latex do not coagulate. We try to check first question, what is latex? Latex is colloidal. Colloidal suspension. Suspension white liquid obtained from the bark of rubber. So the bark of rubber trees. All right, so we try to go for question number 2. What is substance P? So we try to check the substance P coagulate the latex. So this will be methanoic acid. All right, substance Q prevent the coagulation of latex. So this substance is known as ammonia solution. All right, so we try to check question number 3. Explain briefly the process of coagulation of latex that occur naturally. So the first point, latex. Latex contains rubber polymers which covered by negatively charged protein membrane. All right, so we go for second point, the negative charges that present on the surface of protein membrane causes the rubber particles repel each other. All right, so point number 3, when latex left untreated, what will happen? The bacteria on the air will feed on the protein membrane. When the bacteria feed, produce lactic acid. Right, so we go for point number 4. Point number 4, the hydrogen ion from the acid that produced by bacteria will neutralize the negative charges present on the protein membrane. All right, so we go for next point. So the neutral rubber particles. The neutral rubber particles will do what? Will collide each other. All right, so the neutral rubber particle will collide each other and the protein membrane will break. All right, so this causes the rubber polymers are set free. All right, so we move on to the last point. I'll do here the last point. Thus latex is coagulated. All right, so thus the latex is coagulated. So I'll try to read the answer again. When latex contains rubber polymers which are covered by negatively charged protein membrane, the negatively charged or negative charges that present on the surface of protein membrane causes the rubber particles repel each other all the time. All right, so when latex is left untreated, when we didn't add methanoic acid, the bacteria on the air will feed on the protein membrane and produce what acid? Produce lactic acid. So this hydrogen ion from the lactic acid will neutralize the negative charges that present on the surface of protein membrane. The neutral rubber particle will collide each other. Okay, this will break the protein membrane. Thus, the rubber polymers are set free. They will coil together and lump together. And thus, the latex is coagulated. All right, so that's how we answer this question. We move on to the next question. Try to check question number 7. The diagram 6.1 shows the experiment to compare the elasticity of rubber P and Q. The natural rubber has been cut into 2 parts. The initial length is 10. All right, so one rubber is natural rubber. So this is known as natural rubber. All right, this natural rubber they hang by using 500 gram weight, and the initial length is 10 cm. After the weight is removed, the final length will be 12. So this rubber unable to return to its original position. The another rubber strip of natural rubber strip has been chalked in solution X. So this process is known as vulcanization process. The solution X can be sulfur monochloride or sulfur monochloride solution, and this rubber is known as vulcanized rubber. When 50 gram of weight is hanged, the initial length is also 10 cm, and when the 50 gram is hanged and removed, it's able to retain its original position. All right, so we try to check the question. Identify rubber type P. So the rubber type P is known as natural rubber. Rubber type Q is known as vulcanized rubber. So next question, which rubber has high elasticity? That will be rubber Q. All right, explain the your reason. So the formation All right, formation of sulfur cross link in vulcanized rubber. All right, so between the rubber polymers prevent the polymers from slide over each other and able to return to its original length. Therefore, this rubber Q is elastic. All right, the formation of crosslink between the rubber polymers prevent the rubber polymers from slide over each other and able to return to its original length. Question C. All right, so rubber Q is placed into solution X, or what is solution? Solution X is known as sulfur monochloride solution. All right, give one function of solution X, so the answer will be rubber molecules or rubber polymers reacts with sulfur in sulfur monochloride solution and form sulfur cross links. All right, so this sulfur cross link prevent the rubber polymer from sliding over each other. So we try to go for question number D. So here they give us rubber molecules, and this surface of rubber molecules is negatively charged. They add substance X, more positive charges has been added. So this substance Y, they add substance Y, so the substance Y produce more positive charges. So the substance Y can be methanoic acid or ethanoic acid. The methanoic acid and ethanoic acid produce hydrogen ion. All right, so which neutralize the negative charges that present on the protein membrane, and this causes neutral rubber particle has been produced, and this neutral rubber particle collide each other, and thus the rubber is coagulated. I to go for question number C1. The monomer for polyisoprene is isoprene, or with the IUPAC name known as 2-methyl but 1,3 diene. We draw the structural formula of the monomer of isoprene. So how to draw both? We have 4C, 1, 2, 3, 4. So there's a 2 double bond present at carbon number 1, carbon number 2, carbon number 3, carbon number 4. Carbon number 1, after carbon number 1 double bond, after carbon number 3 there is another double bond. So we erase the number. There is a branch present at carbon number 2. Where is carbon number 2? Carbon number 2 is here. So there is a branch present at carbon number 2. So 1, 2, 3. So this is methyl. So each carbon must have 4 bonding. So 1, 2, 3, 4, 5 hydrogen atoms. So this is the monomer structural formula of the monomer of natural rubber, which is 2-methyl but 1,3 diene. So we move on to the next question. So what is substance Y? So they want us to name the substance Y. The substance Y is known as methanoic acid. State the action of substance Y on the rubber molecule. So the substance Y produce hydrogen ion, which neutralize the negative charges present on the surface of protein, right? Protein membrane of rubber particles. So this is the function of substance Y. And to the objective question, the diagram 12 shows the manufacture of rubber glove. All right, so the properties of this rubber glove can withstand oxidation. So they have more resistance towards oxidation. It has less resistance to it. All right, so less elastic, soft. So the answer will be more resistance towards oxidation. All right, try to do more question. All right. Dear student, we move on to the next part experiment to investigate the volcanicity of vulcanized rubber and unvulcanized rubber. So this can come out in Amali question. Alright, so we move on to the first question. So look at the diagram given. Set 1, they use the natural rubber, and the initial length of the rubber is 5.0 cm, and the weight 50 gram or 100 gram of weight is hang at the end of the rubber strip, and the weight is removed, and the length of the weight rubber strip after the weight is removed is measured and recorded. The experiment set 2 is repeated by using vulcanized strip of same length 5.0, and the weight 50 gram of weight is hang, and the weight is removed, and the final length of the rubber strip is measured and recorded. So we more question. So the hypothesis is known as the vulcanized rubber. Vulcanized rubber is more elastic than natural rubber or unvulcanized rubber. So I put here natural rubber. Or the manipulated variable, the manipulated variable will be type of rubber strips. All right, so it will be responding variable. The responding variable, the elasticity of rubber strip, and the constant variable will be initial length of rubber strip. All right, initial length of rubber strip, or we can take mass of weight. mass of weight. All right, check question number 3. The construct a table to record the length of all rubber strip before the weight is hanged, after the weight is removed, and we need to calculate the extension of rubber strip for set 1 and set 2. So the initial length of rubber strip in set 1 is 5.0, and the length of rubber strip after the weight is removed is 6.6. So the extension will be 1.6. And we move on to the set 2. The set 2, the initial length is 5.0. So I put here 5.0. And the final length of the rubber strip, after the weight removed is also 5.0. And there is no extension of rubber strip occur at set 2. So here we put 0.0. On to the question number 4. The question number 4, state one observation that can be obtained from this experiment. So here the length of natural rubber strip increases while the length of vulcanized rubber strip does not change after the weight is removed. All right, so this is our observation. So the observation will be the length of natural rubber strip is increases while the length of vulcanized rubber strip does not change after the weight is removed. Based on the observation at question number 4, we need to state the inference. So the inference will be vulcanized rubber is more elastic than natural rubber. We move on to the question number 6. So state the operational definition for the elasticity of rubber. So operational definition, what done plus with what observed for vulcanized rubber. So when the weight is hanged on the rubber strip and then remove, the rubber strip that will return back to its original length is known as vulcanized rubber, because vulcanized rubber able to return or retain its original length. So we try to do what done in this experiment. All right, so when a weight is hanged on a rubber strip and then is removed. This is what done. All right, so next point, the rubber strip will return back to its original length is known as vulcanized rubber. So if the experiment is continued by adding the mass of weight to the rubber strip will break. Predict which rubber strip will break first and explain your answer. That will be natural rubber strip. So we need to explain the answer. The explanation will be natural rubber strip is less elastic and soft, therefore it will break. All right, so we move on to the question number 8. The natural rubber strip is stretched for few days and the length of the rubber are recorded as given in the table. So we try to check the table. As the number of days increases, the length extension of the rubber strip also increases. So how to do the relationship? As the days increases, the extension of natural rubber strip is increases. All right, so this is the answer. As the days increases, the extension of natural rubber strip is also increases. All right, so we move on to the question number 2. All right, so why the vulcanized rubber strip can return to the length after the weight is removed? Because the formation of sulfur cross links between the polymers of rubber that form through strong covalent bonds. All right, covalent bonds prevent the rubber polymers from slide over one another, and from becoming loose. Alright, so this is the suitable answer that student can write for the answer. Explain why the vulcanized rubber can return to its original length. So the answer, the formation of cross-link between the polymers of rubber that form through strong covalent bond prevent the rubber polymers from slide over one another and from becoming loose. Alright, so we go to question number 9. And the following product are made up of vulcanized rubber. So we have shoe sole, tire, rubber band, eraser. So we need to classify all the product into vulcanized rubber and unvulcanized rubber. So this shoe sole will be vulcanized rubber. Tire will be made up of vulcanized rubber. Rubber band is made up of natural rubber. So I put here rubber band, and the eraser also is made up of natural rubber. Alright, so these are the answers that student must write. So we move on to the next part. On to the synthetic rubber and the properties of synthetic rubber and the example of synthetic rubber. So synthetic rubber is an elastomer. Elastomer that is elastic and can return and will return to its original length and shape when the applied force is removed. The molecular structure of synthetic rubber is same as natural rubber. Synthetic rubber is made through addition polymerization of various petroleum based hydrocarbon monomers. The properties of synthetic rubber are resistance to chemicals such as acid and alkali. It is elastic, not easily oxidized. Alright, easy to clean and handle. Art. Alright, so it's water and oil resistant, is good heat and electrical insulator. So these are the properties of synthetic rubber. Alright, so we try to check the first synthetic rubber is known as styrene butadiene or SBR rubber. The monomer of styrene butadiene rubber is known as styrene, and one more is known as butadiene. Alright, so the chemical equation is given, so we try to check the properties. This styrene butadiene is known as less elastic, can be easily vulcanized, high heat resistance and resistance to corrosion, abrasion resistant, the ability of the material to resist mechanical action such as rubbing, scraping, erosion, and tend progressively to remove material from its surface. The uses of this SBR rubber is used to make car tires and also shoe soles. So please remember this SBR rubber, styrene butadiene rubber, is used to make car tires and also shoe sole. Alright, so next one is under neoprene. The monomer name of neoprene is given here. So please remember chloroprene is the monomer of neoprene. And properties of neoprene, it has I-10 steel strength and also elastic. Alright, resistance to corrosion. It also solvent resistant, not easily flammable, and is used to make water pipe, glove, car accessory, insulating material for electrical wire, Bunsen burner tubing. We move on to the next synthetic rubber, which is known as thiol rubber. The thiol rubber is the monomer of thiol rubber is known as 1,2 dichloroethane, and another monomer is known as sodium polysulfide monomer. Alright, so the properties of this thiol rubber, it has high resistance towards chemical solvent and also oil. Alright, so the thiol rubber is used as petrol pipe, sealant, oil, and solvent storage tank coating. Alright, so next one, silicon rubber. Given example of silicon rubber is given methyl silicon rubber, vinyl methyl silicon rubber, penyl methyl silicon rubber. So the properties of silicon rubber, it can withstand high temperature. Also can withstand low temperature. Alright, and is also resistant to wide variety of chemicals and non-toxic and also inert. Alright, so the silicon rubbers is used to make aircraft component, material for implant manufacture of catheters and prosthetic in medical field. Alright, so next one we move on to the nitrile rubber. The monomer name of nitrile rubber is given here, cryonitrile and 1,2 butadiene and also 1,3 butadiene. Monomer of nitrile rubber is known as cryonitrile, 1,2 butadiene and also 1,3 butadiene. Alright, so the properties of nitrile rubber. The properties of nitrile rubber is oil solvent resistant, it's highly elastic, okay, does not cause any chemical chemical reaction. The uses of nitrile rubber is used to make glove. Next, we move on to use of rubber and the environment. Natural rubber is known as biodegradable. Degradable, which means it can be decomposed or break down by microorganism. Therefore, the waste of natural rubber does not remain forever in the environment. Synthetic rubber is known as biodegradable substance which will remain forever in the environment. The dispose of synthetic rubber waste everywhere can pollute the river, lake as well as causing the blockage of the drainage system, and this can cause flash flood. We move on to point number 4. Use tires collect water which provide good breeding ground for mosquitoes and can cause diseases like dengue. Point number 5. Worn out surface of tire can produce microplastic that can wash into the ocean and harm the aquatic living things. Alright, on to the last part. Try to look at the question given in the diagram. So the diagram shows the nitrile glove which made from the synthetic rubber widely used in medical field. Justify the use of glove. This nitrile rubber is made up of monomers. Monomers are like cryonitrile, right? 1,2 butadiene and also 1,3 butadiene monomers. All right, so the properties of nitrile rubber is highly elastic, resistance to oil, solvent, and also acid. Do not cause chemical reaction. Is a powder free, reduce the risk of allergens which cause discomfort. So this is the answer the students should write. We move on to the question number 2. The tire made up about 90% of natural rubber, 24% of synthetic rubber. However, only very small fraction of used tire is recycled. Describe the environmental pollution caused by this tire. The production of synthetic rubber used in tire requires petroleum which is known as renewable sources of energy. Use tire collect water which provide good breeding ground for the mosquitoes and can cause diseases like dengue. Alright, so we move on to the point number 4. The worn out surface of tire produce microplastic that wash out into the ocean and can harm the aquatic living things. The disposal of synthetic rubber waste everywhere can pollute the river and lake as well as causing blockage to our drainage system. All right, so we try to do few example of objective question. All right, so try to check the objective question. The diagram 1 shows the conversion of natural rubber Q. Rubber Q is known as natural rubber. The process P is known as vulcanization process, and they add sulfur atom. The size of molecule increases. So we try to answer the question, which of the following is explain the process of P? It reduce the elasticity of rubber. Wrong. All right, so it's increase the size of rubber molecules increases. So we already add sulfur atom here. Alright, it decreases the melting point of the rubber. Wrong. To increase the oxidation of rubber. Wrong. Alright, so the answer will be B. Alright, so we move on to the question number 2. Alright, which of the following is the properties of vulcanized rubber? Vulcanized rubber is less elastic. Wrong. Easily oxidized. Wrong. Is hard and strong. Correct. Less heat resistant is wrong. So the answer B. Right, next we move on to the question number 3. What is the purpose of adding formic acid? This formic acid, one more name, is known as methanoic acid. It will produce hydrogen ions which will neutralize the negative charges that present on the surface of rubber particle. It will neutralize all the negative charges that present on the surface of rubber particle. It causes the rubber particles to collide each other, and thus the protein membrane will break. The rubber polymers will coil together and thus coagulated. Alright, so the answer will be to coagulate the latex. Alright, so question number 4. Which of the following chemicals used to keep latex in the liquid form? That will be ammonia solution. Alright, so next one, last question. So the aircraft tire are made up of vulcanized rubber. What properties of vulcanized rubber make it suitable to be used to make aircraft tire? So it maintain their elasticity. It's hard and stronger. Alright, it resistance to oxidation. Wrong. It can take tremendous stress and strength. So the answer will be D. Alright, that's all from me. Thank you very much. Take care.